This is the fourth video on section 5.2, limits and continuity. And so we're going to look at example 135 before we look at definition 132, theorem 133, and theorem 134. This one goes along a little bit with the other, with the previous videos. So let's do example 135 first. We're going to prove that this limit as xy approaches 0, 0, of sine of x squared plus y squared divided by x squared plus y squared is equal to 1. This doesn't surprise us because we learned in calculus 1 that the limit as theta goes to 0 of sine theta divided by theta is equal to 1. So we learned that in calculus 1, so this should not surprise us. But let's look at the proof. So let's let epsilon greater than 0 be given. And because of this thing that we learned in Calc 1, we know that there's a delta. Delta greater than 0, but we're going to also take it to be less than 1. And we'll see why that is when we get to the end of the proof. Such that, let's see, there we go, that and sine theta divided by theta minus 1 is less than epsilon whenever theta and 0 are close. So whenever 0 is less than the absolute value of theta minus 0 is less than delta. All right, so let's suppose we have a point xy that's close to the origin, not equal to. So the distance between xy and 0, 0 is less than delta. That's what I mean by close to the origin, but they're also not equal. And we'll see what happens. So we have 0 less than or equal to the distance of the point xy is from the origin is less than delta. Simplify this. Square both sides here. So we have the square root of x squared plus y squared. We square that. That is x squared plus y squared. We square the other side. That gives us our delta squared. But delta squared is less than delta. Why? Because delta was chosen to be less than 1. Right here. So delta is chosen to be less than 1. That's why delta squared is less than delta. So that is what gives us this inequality. So now what do we have? We have 0 less than x squared plus y squared less than delta. Because of this fact right here. The limit as theta goes to 0 of sine theta over theta is 1. And we've chosen our delta correctly. This term, minus 1, is less than epsilon. Therefore, the limit as xy goes to 0, 0 of sine of x squared plus y squared divided by x squared plus y squared is equal to 1. Definition 132 is the epsilon delta definition of continuity. It looks a lot like the epsilon delta definition of limit, just like they did in Calc 1. This is another version of that. This is another version of the epsilon delta definition of continuity. What did we learn in calculus 1? We learned that a function is continuous at a number c if three things were true. The function existed at c, the limit existed, and the limit and the function value were equal. That's what we learned in calculus 1. That's what theorem 134 is going to say here about functions of several variables. That a function is continuous at a point c in Rn if the function exists there, the limit exists there, and the limit and the function value are the same. So that is a way to characterize continuity of functions in Rn.